Hi everybody. These notes are for August 11th for Tuesday, and they'll be due Wednesday. The homework will be due Wednesday. It's section 1.2, day 2. Test an equation for symmetry. We're going to look for symmetry. Another tool for graphing equations is to check whether the graph of the equation has symmetry. There are 3 types of symmetry to look for. A graph is said to be symmetric with respect to the x-axis if for every point xy on the graph, the point x negative y is also on the graph. So if we have the x-axis right here, if xy was on it, then x negative y was also on it. It's symmetric with respect to the x-axis. Right? This is a line of symmetry, the x-axis, and this is a reflection over the x-axis. A graph is said to be symmetric with respect to the y-axis if for every point xy on the graph, the point negative xy is also on the graph. So if we have the y-axis this time, and we have a point xy on the graph, then negative xy would also be on the graph, and the line of axis of symmetry is the y-axis this time. A graph is said to be symmetric with respect to the origin if for every point xy on the graph, the point negative x negative y is also on the graph. So if you go to like 3, 2, that's xy, and then you go to negative 3, negative 2, it goes straight through the origin at 180 degrees. It's symmetric with respect to the origin. Negative 3, negative 2. Symmetry with respect to the origin is the same as being symmetric to both the x and y axes. So if it's symmetric to both, then it's symmetric to the origin. So here's a picture. Some pictures better than my pictures or more complicated than my pictures. This is symmetry with respect to the x-axis. Here's this graph and here's this graph right on the other side. The x-axis is the axis of symmetry. And so the y values all turn to negative, x and then minus y. Here's symmetric to the y-axis. The x's all become negative. The x's all become the opposite. And it's symmetric with respect to the y-axis. And then the origin, both the x and the y become negative, or the opposite. So this is symmetric with respect to the origin. This point x1, y1 goes to negative x1, negative y1. It goes right through the origin. So the way we test for symmetry, we're going to test this for symmetry. We're going to find the intercepts, and we're going to test for symmetry. To find the x-intercepts, we let y equal 0. And to find the x-intercept, we let x equal 0. So if we let y equal 0, 0 equals x squared minus 9 over x squared plus 2. If you cross multiply, 0 times x squared plus 2 is 0 equals x squared minus 9. X squared equals 9. X equals plus or minus 3. Because remember, 3 squared is 9 and negative 3 squared is 9. So the intercepts are 3, 0 and negative 3, 0. They're always in ordered pairs. Intercepts are always written as ordered pairs. To find the y-intercept, we let x equals 0. So we just substitute 0 into the equation. 0 squared minus 9 over 0 squared plus 2. And we get negative 9 over 2 So it's 0, negative 9 over 2 is the y-intercept. To test for symmetry, there's 3 tests that you're going to do for each problem when it says you're going to test for symmetry. To test for x-axis symmetry, you replace y with negative y and simplify. So if we look at this, instead of y, we put negative y in. X squared minus 9 over x squared plus 2. And then you solve for y. So it's going to distribute a negative to the other side, because you multiply both sides by negative 1. And when we distribute the negative here, it's going to be negative x squared plus 9 over x squared plus 2. Is this the same equation as the one above here? They're different. So this is what you write. Not equivalent equation. Because they're not equivalent equations. 3 dots means therefore not symmetric with respect to x-axis. That means it's not going to be symmetric to the origin, because it has to have both to be symmetric with to the origin, but we're still going to do the test. Not symmetric with respect to the x-axis, not equivalent equation. The 2 equations are not the same. They have to be identical for it to be symmetric with respect to the x-axis if we put in negative y in for y. To test for y-axis symmetry, we replace x by negative x and simplify. So we write y equals negative x, the parentheses are important, squared minus 9 over negative x squared plus 2. And we get x squared minus 9 over x squared plus 2. If we look at this equation and we look at this equation, they're the exact same. So we write equivalent equations therefore symmetric with respect to the y-axis. So that was for x-axis symmetry, y-axis symmetry. This one's for the origin. You replace x by negative x and y by negative y, and you simplify. And you do both. So negative y equals negative x squared minus 9 over negative x squared plus 2. Negative y, so you do both, the negative x and the negative y, both of them at the same time, equals x squared minus 9 over x squared plus 2. And then you multiply both sides by negative 1, and you have a negative here to distribute. And you'll have negative x squared plus 9 over x squared plus 2. That's equal to y. Y equals this, because you multiply both sides by negative 1. And we got this. And this is not equivalent to the original equation. So we write not equivalent equations therefore not symmetric with respect to origin. So there's an example of how to test for each type of symmetry. And then we're not going to use a graphing device to determine our results. How to graph key equations. It says graph y equals the cube root of x by doing any of the following. Find the intercepts, test for symmetry, plotting some points. So if we were going to use a table, you do -1, and what's the cube root of -1? You get -1, -1, because -1 times -1 times -1 is still -1. If you do the cube root of 0, 0 times 0 is, times 0 again is 0. So you get -1, -1, and 0, 0. You could also try 1. The cube root of 1. 1 times 1 times 1 is 1. How about the cube root of 8? What number times itself gives us 8? 3 times. It would be 8, 2. 2 times 2 times 2 is 8. So we go to 8, 2. And then -8. The cube root of -8 would be -2, because -2 times -2 is 4, times -2 is -8. So -8, -2. So that's what the shape of the cube root of x looks like. And which one do you think is symmetric with respect to? Does it flip over the x-axis and have something down here? Does it flip over the y-axis and have something over here? No, it's symmetric with respect to the what? If this is xy, what point is this? -x, -y. So it's symmetric with respect to the origin. And the reason is, if xy is on the graph, then -x, -y is on the graph. That's the definition of being symmetric with respect to the origin. So I'll put your homework up. I'll tell you what assignment to do and give you the pages after I upload this video. Okay? So this homework, as well as homework number 1, number 2, and number 1 are both due on Wednesday when I see you. Thank you.